Hello, friends. Don't forget to like and subscribe. Just thought I'd say that at the beginning. We're required to say it on YouTube and the YouTube salute. Okay, let's get going on this. Um, Continuing our study of trigonometric functions and learning a little bit more about notation. We're just building off of everything that we know, right? And we're introducing other concepts, things that we already are aware of, just pointing them out and then tying them in. Happy Pi Day, by the way. Today is March 14th. I don't know when you're going to watch this, but today is Pi Day, so happy Pi Day. Um, so we start with a question here. Are these two equations equivalent? That sine of x equals 1/2 and inverse sine of 1/2 equals x. So in other words, if I were to solve these two, would I get the same thing? The place where sine of x equals 1/2 would be both of these places, right? Here and here. But the thing is about this one, inverse sine has a restricted domain, and so it would only be here. So these two things are not equivalent. So you got to be careful about this. If you're given sine of x equals 1/2, what are the values of x? What are the solutions? There's more than one solution, right? Like, for example, this is pi over 6 and 5 pi over 6. Right? But for this one, there's only one solution, and that would be pi over 6. Okay, so we got to pay attention to the domain restrictions and that sort of thing. But when it comes to solving something like this, sine of x is 1/2, there are two solutions here, but there are actually lots of solutions. You can keep going around and around and around. So the solutions here would be uh, pi over 6 plus, and then any multiple of 2 pi, because 2 pi is another, goes around one more time. Also, right, 5, that's not a 5 pi over 6 plus k times 2 pi, where k is some integer, right, or some constant. And so it's important for us to keep that in mind. That applies for sine and for cosine, 2 pi. But for tangent, then the period is just pi. So here are some instructions for that, some sort of general guidelines. Then we have sine of x is 1/2. It would be sine of pi over x plus 2 pi k. All right, they put the k in a different place. Doesn't matter, commutative property of multiplication. Or 5 pi over x. And then again, cosine, you would do the same thing. Pi over 3 for cosine, right? Cosine is 1/2 at pi over 3 and 5 pi over 3. But again, plus 2 pi k, because you can go around. But for tangent, again, the period is only pi, so it's plus pi k, because pi is going to get you to that next spot in the tangent graph, in the tangent function. Example 1, where does cosine of x equal negative root 2 over 2? If I draw a circle, just to picture this, this doesn't take that long to do, so it's best just to do it. A lot of times I try to do it in my head, but best just to do this. So negative root 2 over 2, that's here, right? The negative values. And so this is 3 pi over 4. And we're going to have to add plus then any multiple, all these periods. And then also 5 pi over 4 plus 2 pi k. Okay. Same idea here. Where does sine of x equal negative 1? Well, sine is the y value. Negative 1 occurs here. That's only one spot. And so this is going to be 3 pi over 2 plus 2 pi k. I don't have two different positions to be able to, so I only have one set of solutions, you could say, one expression for the solutions. We should write x equals, forgot about that. X equals. Find all the solutions to the equation, tangent of x equals 1 over root 3. So 1 over root 3 is going to be 1/2 over root 3 over 2. So where is that? Or it could be negative, right? Plus or minus, because if they're negative, so we're in the first and also in the fourth, the third quadrants, and sine over cosine. Sine is 1/2 at this point here at pi over 6, right? And so, and then also over here at 7 pi over 6. So the answer is pi over 6. Now, the thing is, notice it's pi degrees apart. So I only need to put pi over 6 and then plus 2 pi k. That covers all the other solutions, right? That covers, for example, so if k was 1/2, uh, then actually we don't have to do 2 pi k. Actually, it should be pi k. I take this back. Plus pi k, like I said before. X equals, right? And then that covers both solutions, right? Pi over 6 plus pi gets you to the third quadrant and then back to the first, third, etc. All right, so here's the general way of solving these types of equations, right? So first, isolate the trig function. So you have just sine or cosine, whatever, on one side, and then everything else on the other side. And then find the corresponding angle measurements on the unit circle. Think about any domain restrictions, and then write out the solutions. Okay, so in this case, where is so 6 sine of theta equals √3, or 3 times √2. Okay, so isolate the trig function. 3 over 6 is, so √2 over 2. In the unit circle, sine is the y. This is positive, so this is going to be here and here, √2, the middle, right? So I think about pi over 4. And then over here is 3 pi over 4. So x, or not x, we got theta here. Theta equals pi over 4 plus 2 pi k. Theta also equals 3 pi over 4 plus 2 pi k. All right, another one. F of x equals 3 plus 2 cosine x, and g of x equals 2 in the xy plane. What are the x coordinates of the points of the intersection of the graph on the domain 0 to 2 pi? All right, so let's see. If I want to know when they are equal, right, then I set them equal to each other. So 3 plus 2 cosine of x equals 2. So I'm looking for these places. So 2 cosine of x, I'm going to subtract 3 from both sides. So 2 minus 3 is -1. So cosine of x equals -1/2. So negative value for x, and it's the smaller value of x. So that's going to be the, I think the 120 degree. It's closer to the y-axis there. And so this is going to be 2 pi over 3 here, and then 4 pi over 3 down there. And that's it. I can't go around anymore because I have this domain restriction. And so those are my solutions. Now, if we want to square a trigonometric function, it can get a little tricky because we've got a bunch of things in there. Where we've got the letters, and then we've got the variable. So we want to have a notation, a commonly understood notation, a convention for squaring sine. And so we can write it one of two ways, like this, or like this. If we bring it in like sine to the power of something, of x, the one time you don't really want to use that is when it's to the -1, because then it's ambiguous, right? If you have sine -1 of x, like, is that sine, inverse sine? So just be careful about that one. Okay, and so that's just a notation issue. And then we continue. So in example 6, I want to find the zeros of this function. So I write 3 minus 4 sine squared of x equals 0. I'll subtract 3 to the other side and multiply by -1. I'll do that in one step. So 4 sine squared of x equals 3. Now I could take the square root of both sides because I've got the 4 there. That would just turn into 2 sine x equals square root of 3. But what I'm going to do instead is move the 4 over. So I get sine squared of x equals the square root of, not the square root yet, sorry, it's 3. Now I take the square root, 3 over 4. Okay, so sine of x, I'll get it right. Relax. Plus or minus √3 over 4. You got to be careful there because it is plus or minus. Add that complication by doing it this way, by having that square there. And so here, that's these values. It's the pi over 3 values, right? So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. That's what I get. Okay, example 7. I want to find the places where theta, cosine squared of theta equals negative cosine of theta on the domain of 0 to 2 pi. So cosine squared of theta equals negative cosine of theta. So I'm going to add cosine to both sides. So I get cosine squared of theta plus cosine of theta equals 0. Factor out cosine. So cosine of theta times cosine of theta plus 1 equals 0. And then cosine of theta equals 0 when theta equals pi over 2 and 3 pi over 2. And then cosine of theta plus 1 equals 0 when cosine of theta equals negative 1. And that happens when theta is equal to pi. So those are all my solutions there for that. In example 8, same kind of thing. Or rather, I'm given two functions, and I want to find where they intersect. So I set them equal to each other, and then I'm going to solve for x. So 2 sine squared of x equals root 3 times sine of x. So this is similar to the one that we did before. 2 sine squared of x minus root 3 sine of x equals 0. Factor out sine, so I get sine of x times 2 sine of x minus root 3. That equals 0. Okay, so I'm looking for the place where sine of x equals 0. And sine of x is going to equal 0 at 0 and pi. So x equals 0 and pi. Then I'm looking for the place where 2 sine of x minus root 3 equals 0. So that's where 2 sine of x equals root 3. And sine of x is root 3 over 2. So what are the places where sine of x is root 3 over 2? That's going to be these places here. So pi over 3 and 2 pi over 3. So x equals pi over 3 and 2 pi over 3. And that's it. So on pi day, you probably understand pi better than you have before, and maybe better than you ever wanted to. But thanks for watching. Again, don't forget to like and subscribe. I'll see you next time.